Hello everybody, thanks for checking out this awesome video. This one's going to be about phase diagrams, straight up phase diagrams. So what you should have received today was something that looks kind of like this. In our gases unit, we're obviously talking about pressure and temperature, obviously gases. But again, believe it or not, phase changes can occur not just with temperature changes, but also with pressure changes. So normally when you think of, okay, you got water, it's or H2O, it's ice, you heat it up, turns it to a liquid, heat it up more, turns it to a gas, hooray, exciting. But you can also change phases based on pressure. So there definitely are the two distinct differences here between obviously the pressure and the temperature. So pretty much a phase diagram is just a graph. So it's a graph, it's got two lines up here. Usually they could be straight, one could be curved, whatever, both could be curved. Pressure is normally on the y-axis, temperature on the x-axis. Normally there are numbers, but for just our notes, I'm not going to care about that. And there also are three distinct phases for each. Solids tend to have low temperatures and a lot of pressure on them. Liquids are somewhat in between with temperature and pressure, while gases tend to have low pressure and then high temperatures, all based on, again, particle molecule movement. So what we're seeing here are a bunch of random lines. And again, it's called a phase diagram because we have the three phases, but also a phase change diagram because there are a bunch of changes that can occur. So a bunch of the changes that you have obviously have heard of before, we have solid, solid to liquid, liquid to solid. So again, what we're seeing is that if you increase or decrease the temperature, we'll get a phase change from solid to liquid or liquid to solid. So on our line, if we actually have an arrow going from solid to liquid, so if the temperature goes from something over here to something over here at a certain pressure, it's going to go from solid to liquid, which is obviously our melting. And then if it goes the other way, obviously this is our freezing. There are some other words that are used for those, but melting and freezing is fine. Let's see, the other one we really know a lot about is liquid to gas. So again, this could happen with temperature change or with pressure change. It's actually really weird. I'll talk in a few minutes about water. So if you're going again from liquid to gas, that is vaporization. But then gas to liquid is straight up condensation. Okay. And our last one, which doesn't happen as often, is the solid to gas. Now this happens, it can either be with pressure difference, up and down, temperature difference, side to side, or it could be both, doesn't matter. So let's say we're going from solid to gas or gas to solid. Solid to gas, that's dry ice. Dry ice is called sublimation. That's when solid carbon dioxide turns straight into a gas. It doesn't melt and then vaporize. It actually straight up sublimates, or sublimation. Gas to solid, not as common. It's actually called deposition, but we're not going to really worry about that. Cool. So yeah, there's really no memorizing here. I mean, you've all heard of these phase changes before. Now, normally on assignments or whatever, you'll be given like, hey, this substance goes from a certain temperature here to a certain temperature here. What happens? Well, if it goes from this to this, it sublimates, turns from a solid to a gas. That's the phase change. If the pressure goes, let's say, from like this, like to this point, then obviously our gas is turning into a liquid, and so it is condensing. At whatever temperature this would be, like it turns again. It starts at this pressure and it goes to wherever that is, like this pressure. You will have numbers on the sides. There are two there are two important points on these graphs. That's one of them, and that's one of them also. Oops, sorry about that. The lines on the graphs, that's kind of the equilibrium phase. So if you had a substance at, let's say, this point on the graph, like right on the line, I know this doesn't look like it, but right on the line actually is a liquid and a gas simultaneously, which is very normal, not a big deal. It's kind of like when water is boiling. It's a liquid at 100 degrees and it's also a gas at 100 degrees. It's just changing phase. So anything that's on the line, the phase change is occurring or the two substances are in equilibrium with each other. But the two sweet points here are these ones. This one is the first one I want to mention. This is called, again, it is in your vocab. I'm going to circle it and just bring it over here. This is called your triple point. This is crazy. I'm going to post a video of the triple point of a certain substance soon. Triple point is exactly what you think it is. So up here, like over there, this means that something is either melting or it's freezing at whatever temperature this is, at whatever pressure this is. But if you eventually change the pressure and the temperature just enough for the substance, it actually is doing all the phase changes at the same time. So all 6 phase changes are happening at once. It's crazy. So yes, you'll have some solid that's melting at the same time that the liquid is vaporizing. At the same point, the gas is depositing. It's really weird. All at the same time, these things are happening because that's the what's called the triple point. All 3 phases in equilibrium with each other. So it's kind of crazy. There's also this point, which is actually called the critical point. You'll only see it between the liquid and gas phase. This is basically a point in which if you have that pressure, so whatever pressure this would be, and that temperature, anything like above here is pretty much in a liquid gas phase all by itself. You can't really distinguish between the two. So it's kind of rare to get something at its critical point because it has to be, again, under super intense heat and also pretty decent pressure. So critical point just means you're at a certain pressure and a certain temperature, and after that, like the liquid and gas phases are indistinguishable. So it's just looks kind of weird. Yeah, so it's pretty much just pressure and temperature affect the phase of every single piece of matter. So the one cool thing I was going to say about water is that obviously to boil water, you just heat it up. So you let's say water is here, you heat it up. Oh, look, it turns to gas because it went from liquid to gas and you heated it. But what you could also do is, let's say you've water at a certain temperature. If you just decrease the pressure while keeping the temperature the same, you can actually boil it. So I have actually had people touch boiling water before, or like 5 seconds after it's been boiling, and it actually is ice cold, or it's just normal temperature, because all you do is decrease the pressure pushing down on the water and it starts boiling because the water wants to go away, so it starts to boil because the pressure decreases. It is actually really cool. So I'll try to post a video of those when I can. Sweet. So that is the phase diagram. Sweet. Thanks for checking in.